Hi, my name is Manuel Linus,
And my name is Scott Lindner.
and we're co-directors of the Huck Center for Malaria Research at Penn State in the Department of Biochemistry and Molecular Biology.
In this video, we'll be talking to you about malaria, which is a major global health issue.
Malaria is a devastating disease that currently affects hundreds of millions of people every year, resulting in nearly 600,000 deaths, mostly in small children and pregnant women. Malaria is caused by single-celled eukaryotic parasites called Plasmodium that are transmitted between humans by mosquitoes. There are two species of Plasmodium parasites that cause most of the infections in humans: Plasmodium falciparum, which is the more severe form and accounts for most of the disease in sub-Saharan Africa, and Plasmodium vivax, which can have prolonged relapses. The life cycle of the malaria parasite is complex and involves development in both the human and the mosquito. Human infection starts with the bite of an Anopheles mosquito. The parasite, called a sporozoite at this stage, makes its way into the liver, where it divides and eventually releases tens of thousands of infectious merozoites, which invade the host's red blood cells. The parasites replicate within the blood, causing waves of fever every 2 days. This blood stage cannot be transmitted to mosquitoes, but a sexual form can be picked up by mosquitoes, which then completes the life cycle. Plasmodium parasites are transmitted only by specific species of Anopheles mosquitoes that are found throughout the world and cannot be spread by contact with infected people. Because the Plasmodium parasite must be transmitted through a mosquito, transmission must occur where the mosquitoes can live. Today, infections are concentrated in 3 major areas around the world: Sub-Saharan Africa, Southeast Asia, and Central and South America. Historically, malaria infections were much more widespread and were introduced to eastern North America with the arrival of European colonists. These infections continued for centuries despite efforts by governments and scientists to understand the parasite and prevent its transmission. In fact, the United States and Italy were only declared malaria-free in the middle of the 20th century following World War II.
No one method alone cleared a country of malaria. It was the combined effort of complementary approaches that produced this feat. Drugs that could kill the parasite were developed and then widely distributed by many countries. Insecticides, such as DDT, that could be sprayed inside houses and where the mosquitoes breed, were extremely effective at cutting down the mosquito population. Improvements to housing, such as more solid construction methods and metal window screens, helped to greatly reduce contact between the mosquitoes and people. And perhaps more importantly, campaigns designed to educate the people about how malaria is spread were key in helping them understand why these treatments were necessary. Today, the most effective control measure is the use of bed nets, which prevents transmission from mosquitoes to sleeping people. As we develop new drugs to treat malaria, the parasites evolve resistance to them, including our current first-line drug, artemisinin. Many of the drugs that used to work no longer do in large parts of the world. Artemisinin, in combination with other drugs, still works in sub-Saharan Africa, but if resistant strains were to move in, it could be a disastrous situation, as there are no new approved drugs waiting to take its place. A vaccine for malaria would be a game changer, a much-needed complement to the existing controls.
Although there are global efforts pushing to make this happen, no malaria vaccine has yet been approved and deployed for global distribution.